Hello everyone, welcome back to alkaline hydroxide 784. Today we'll be looking at a very important problem humanity has to deal with, our energy consumption. Day by day, the energy used increases, and sadly, a large portion of it is traditional energy use rather than cleaner energy. And the worst part is that even if new tech exists, lower income countries don't have access to this tech, or the politicians prevent it from happening. Anyways, rambling aside, I'm here today to explore some of these options. And we'll also see how they apply to Singapore because why not? We can just see how the different energy options works in a case study or in that sense. First we need to get up to speed with what we already have here. Like what are the energy sources we use right now? So I think most of you would know that natural gas is the main source that we use in Singapore. But we also have some solar energy and some waste to energy kind of plants as well. So that's the first thing that I can get from the figure here. And the other thing that we can find out is that the major energy consumption in Singapore is in terms of industry rather than households. And I guess that kind of makes sense because factories always consume a lot of energy. Yeah. Okay, so now that we know about it, let's look at what are the ways to solve the energy crunch and see how they apply to Singapore. Okay, so the first one is a rather interesting one, and it involves carbon fuel that comes from the air. Yep. The first idea is to literally regenerate fuel and keep using it in a cycle. This is a form of carbon capture, and the idea is to be zero emissions by, just recouping back the carbon. So, how in the world is this done? Well, when you burn fuels, the heat provides activation energy to break the bonds in the fuel and also in oxygen. And when the two of them recombine, you get carbon monoxide or carbon dioxide. And the total energy released is, there's a net energy released. And that energy is then giving us the electricity. So in order to carbon capture, we need to reverse the process, which is to bring CO2 back to fuel form. So where is this done and how is it done? Well, there is an actual place in California, an actual plant, and what they do is they use direct air capture, so they take CO2 directly from the air. And the way that they do it is they use something like potassium hydroxide or calcium hydroxide to capture they scrub the air and then capture the CO2 and convert it to carbonate anions. And these carbonate anions are then, kept along with the cation, and it becomes like a salt. And this salt is then heated to release the carbon dioxide, and that is brought through the Fischer-Tropsch process. Although that one is more for carbon monoxide rather than carbon dioxide, but they use a process to combine it back into fuel, which is like natural gas kind of fuel. And you can watch the videos in the list for more information on this. So anyways, this seems like a lot of work. I think it would be easier to plant a bunch of trees just to get that carbon. But anyways, can this be done feasibly in Singapore? I suppose so, as long as we can find some space and spend a bunch of money to get those specialized equipment that they use. Even though technically they are being somewhat affordable with the equipment, but yeah, we need to invest in those particular infrastructure that is required for doing this. And we can very well do it if we want to, so it's not necessarily particularly hard to do. Maybe it might be a bit expensive at the moment. That's probably one of the main limitations at the moment. And the thing is, we already do capture a lot of stuff that comes through the exhaust. Although I'm not sure if we are capturing carbon dioxide per se, we're capturing a bunch of other more harmful gases from the factory exhaust. And we already use natural gas as our fuel, so technically this will be compatible with our existing, industry. And whatever stuff that's produced from here would be useful for us. So in theory, it's possible, but is it really the best solution? In my opinion, yeah, it doesn't seem like the best solution because it's more of like ignoring the problem and just trying to, use capture carbon dioxide from the air and use it again. But it could be used as a combination with, while like you're developing and building other renewable sources, because those things take time to build. I've noticed that as I watch videos about the logistics of building things like this, and they need many years to build and they require a lot of money in order to build. And I think this would probably be a bit easier to build compared to some of the renewable energy sources. So yeah, maybe it could be used as a combination instead of on its own. Yeah. So earlier I was talking about the fact that it would be easier to just plant a bunch of trees or something like that. Well, that kind of method is already a thing, and you've probably heard of it: biofuels. So, what exactly are biofuels? Well, they're usually made from crops like corn, palm, yes, palm, take note of that. Sugarcane, basically, they use the bagasse from the sugarcane, which is what comes after you squeeze out all the active sugar water. They use rapeseed and even other things, other kinds of plants. And you can even use old cooking oil to make biofuel. So generally, these things are usually meant as a replacement for petroleum and car fuel and things like that, rather than for electricity. And the way it works is by having ethanol in it, because ethanol is flammable and it's a pretty decent fuel which you can use for burning. It's also somewhat volatile enough to work as a car fuel rather than, unlike some other fuel sources. And yeah, it could be in theory be used for electricity if we have the fuel plants for getting biofuels and stuff like that. And what's more, Singapore has already actually signed as part of ASEAN this Cebu Declaration on East Asian Energy Security Pact. Why are all the ASEAN things so long? All the pacts are so long. Okay, anyways, and this pact aims to have more progress in biofuels. Yes, biofuels specifically. And Malaysia and Indonesia are already doing some things with regards to biofuels. They're trying to incorporate it into their petroleum industry. And they have quite a lot of potential, because palm trees. There's a lot of palm trees there in Malaysia and I think in Indonesia as well. So they definitely have a lot of potential for biofuel. So maybe we might buy from them if we want. We don't really have a lot of capacity to make our own biofuel, but we could use it. That's about as much as I can say. But apart from biofuels, Singapore actually uses a different method, which is, waste to energy, which is what I mentioned earlier while looking at the figure. So we have an actual thing to produce electricity from waste. And by waste, I mean basically what you throw in the dustbin. And if you go to Woodlands Waterfront Park, you can see, those two columnar red and white things. And that actually belongs to the Senoko Waste to Energy plant. Isn't that cool? We are literally making electricity from trash. And the way it works is, actually I visited Senoko before, and the way it works is that they first collect all the trash from the trash trucks that come in. They just collect it and then they dump it into this huge um, room sort of thing, like this huge place where it just collects up the trash. And the trash is then, like, once they're ready to start burning, they will start burning the trash bit by bit. Like, it will be pushed into the incinerator area using this big arm thingy, like this robotic arm that can push it in. And they will do it for a certain period of time. Like, they don't do it continuously 24/7. They do it maybe for 2 or 3 days, and then they take a small break, and then they do the next round. So that's how the Senoko plant works. And it's not just Senoko, there's also one in Tuas and I think another one somewhere else. So you can find more information on this and it's pretty interesting. And the end result is actually the thing that ends up getting buried in Semakau. Or in the future, we might use it as construction material. So basically, it's like some ash and stuff. And all the poisonous stuff is generally blocked out. It's filtered out from the exhaust. Yeah, so that is the waste to energy thing that we have here in Singapore. So in theory, we could in turn also burn biofuels and things like that. We can definitely use that as an electricity source. The only problem is we cannot really grow it ourselves because we don't have a lot of palm trees here. We have to buy it from maybe Malaysia or Indonesia. Anyways, now let's get to the renewables because everyone talks about renewables more, right? So first up, we look up at the sky and immediately turn back down because the sun is too bright. Yep, we are looking at solar energy right there. The sun produces so much energy that if we could capture all of it, we wouldn't need to worry about using anything else. Wow. But I'll talk about how that's like one such thing at the end of the episode. But for now, I'll just talk about solar energy in general. So, unfortunately, there are still some limitations to solar energy panels' capacities, and those limitations start all the way from the source coming into Earth, and that would range from UV absorption in the atmosphere. Yeah, you know, right? Like the stuff that we need protection from is also stuff that could be used for solar energy. So since it's blocked by the ozone layer, we have lesser stuff for getting electricity out of. But okay, we still get a decent amount of sunlight energy coming in, and you could use it, right? But the problem is you need to actually absorb a decent wavelength range in order to maximize the energy capture. That means it's very hard to capture literally all the wavelengths of light that comes in. And if you don't know what I'm talking about, well, visible light itself contains of various wavelengths of lights, from the red light to the blue and ultraviolet light. They all have different wavelengths, and even plants don't capture all of the wavelengths. There's a reason why the plants are green, because plants actually do not have, like, they kind of reflect green light, so they don't absorb the green light, even though the green light is one of the more abundant lights in the sunlight. The plants don't really absorb the green light because the combined sum of the rest of the light is more useful for the plant in general. So likewise for solar panels, we try our best to absorb as much light as possible, and that's why the solar panels generally look black. But it still reflects some light off, and that's why they look shiny. They look a bit shiny because they're reflecting some light, and that means not all of the light is actually absorbed by the solar panel. And sometimes, even if the light is absorbed, it sometimes just heats up the solar panel rather than truly being absorbed into the silicon and used as in terms of photovoltaic energy. So you have to worry about the solar panels overheating as well. And we also have to worry about finding enough space for these things because they can be quite huge. They take up quite a bit of space. And we have to make sure we don't have a shortage in the night because the night has no sunlight. So we cannot capture it in the night, and instead we have to figure out how to store the excess from the day in batteries or some other way of storing it in order to use it in the night. And that's another problem in itself. The battery storage can be quite cumbersome because the batteries aren't very small. They are quite big, and you need quite a lot of batteries in order to store all the excess electricity. And yeah, you can see more details of such limitations in the videos, and I do recommend you to go through the links and everything because that would help you to understand it even better if you are interested to know more. So limitations aside, solar is still one of the more feasible things for us. In fact, we have it as one of the things in our electricity list there. And solar panels are becoming more affordable by the day. So yeah, we have a bunch of solar panel companies here in Singapore, and we have photovoltaic for production here in Singapore. But we do have to be a bit innovative about where we keep these solar panels. Generally, you have to keep it on the rooftop of buildings and maybe on a water body that is most likely just a reservoir or something like that. But in a way, it would be more possible for us to actually use more solar energy in the future because we do have a lot of sun. We are in the tropical, you know, equatorial region of the earth. So it is more than easy for us to capitalize on solar energy. Okay, cool. But another thing that we need to worry about here when it comes to solar energy is that we would need more battery development in general, like overall development in batteries for storing this energy. And the other option is to just make sure you don't only rely on solar energy and do it with other methods. Right. So what else can be found in the sky? Wind, of course. It's like the only respite we have left in the hot Singapore weather. Huh. Anyways, it seems like a good idea in theory. Just set up some windmills along the coast or somewhere. Call them super mills and make them a tourist attraction or something because that's what we like to do. But there are problems with wind energy in general because, yeah, I'll tell you right now. So wind energy is clean. It is pretty cool. They like some big thing with looks like a big fan just spinning in the air. But it requires us to build windmills with really big blades. As I said, they are just like it just look like it's really big fans. And the problem is, it can be problematic for birds. And I don't want, the precious birds to be dying from hitting these windmills. And as we all know, Singapore is a prime location for the migratory birds to come and nest, and then they'll continue on their journey. So it's like a stopping point, just like how Singapore is a pretty important terminal for flights going from different parts of the world. And I don't think we really want to harm these birds that are coming into Singapore every day. We also don't really have a lot of space here in Singapore because windmills require a lot of space. In fact, wind farms are usually found in like large expanses of like expansive land in big countries, which means if let's say you don't have a clear plot of land, you have to clear the land, which would affect animals and birds that live there. And the important keyword here is the word big countries, the phrase big countries, I mean. So that would mean places like US, India, China, which have a lot of land, and not Singapore. Singapore is small, it is not a big country. And by the way, my mention of tourists and stuff, that's a sarcastic thing. Windmills actually repel tourists, so no, it's not gonna help us with tourism either. So I wouldn't really want a whole bunch of windmills here in Singapore. But the thing is, there is at least one big windmill in, not the mainland, but in Semakau. I mean, Semakau has already been made into a trash dump to some extent, so might as well just put some windmills and solar panels there and make the most out of it. And as you can see, we can't really keep a lot in the mainland, but can we have such, offshore versions or maybe even floating windmills? Because we managed to have one in Semakau, maybe you can have those that are floating and not within the mainland per se. So in terms of floating, well, you might be wondering, is that even possible? Yeah, that's a thing. There is a thing called a floating windmill. And I can watch the video from Le Monde, which is, French. But there are such floating turbines used near France. I think it's a pretty new thing because there aren't that many there. But the thing is, apparently it doesn't collapse. It works somewhat, and it seems pretty promising. But I'm not sure how well it would work here because I know the waters can be quite choppy and, quite turbulent. So I'm not sure how well those things work here in Singapore or like offshore in the sense. But we could still try. We can probably try having such things. It is more promising than having it on land. But anyways, we also need to still worry about the birds because it's not like the birds will avoid it or something. They might still fly in that area, so we have to be worried about all these things before we install any wind turbines anywhere. So yeah, before I start sounding like a windmill hater, let's move on. So if turbines in wind doesn't work, what about those in water? Well, in fact, there are two ways to get energy from water, which is the hydroelectric dams and wind and like water turbines. So those are two ways: the hydroelectric dams and water turbines. And for the first one, we use a height difference to get water to transfer the gravitational potential energy into electrical energy. And it's used in all sorts of places. Like these dams are found in many places in Europe, in US, and in some Asian countries. And I think like one of the more like in terms of the videos, right? The video actually mentions one in Korea, so you can even look at that example. So would this work in Singapore? Well, the first thing is the hydropower plant requires land, a lot of land. We need some fast moving water and we need like decent height gradients for the water to move. And Singapore doesn't really have such things. Basically, the rivers in Singapore are mostly artificial, so we we don't really have a fast moving river stream in the sense. It wouldn't really work here. But Singapore could, in theory, buy it from another place. And in fact, there was such a deal. Like, I'm not sure if it's actually a thing, but there's a news about Laos being willing to sell us hydropower in the sense. But as you can see, even in other countries, even in Laos, there could be limitations to doing hydropower. So recently, Laos had like a drought. So basically, if a drought comes along, you're out of business. And even if you're still in business because you don't have a drought or anything, the dam could have environmental impacts on the wildlife in the river. So yeah, if you think about it, a dam basically prevents fish from going through it. It's like blocking the way. And I've heard that dams can create this situation where the water on one side of the dam tends to become warmer because there's not enough circulation of water. So the temperature gradient still stays there and the river becomes warmer on one section, and that could be detrimental to the fish because they need a certain cool enough temperature to survive, and the warm waters could be dangerous for them to stay alive and they may end up dying. So dams aren't really the best things to be having in general, unless the water itself already doesn't have a lot of life in it. Yeah. So what about underwater turbines? There were some cool new turbines tried out as part of this project. And it was somewhere in, I think in near UK, like that side. So they did somewhere offshore and they had some technical issues because the waters there are quite high speed. So in fact, water power kind of stuff is generally used in UK and yeah, like that area because it's a bit more temperate climate, and for them water provides a more consistent energy source compared to the sun, because in London the apparently it's just rainy days all the time and not exactly very sunny there. So for them this is like a more worthwhile energy source compared to solar energy. But here in Singapore, we have a lot of we have a lot of sun, so I don't think we really need to have water-based energy systems as much. But yeah. So would the water turbines work here? Well, technically it could, because apparently there is something that is going on in Sentosa at the moment. They actually have a bunch of water turbines installed there. And since our waters aren't as high speed as the ones in UK, it could actually work to keep a water turbine and not have to worry about it getting damaged. Of course, you have to still worry about wildlife again, because you don't want things like, you don't want marine creatures getting into the blades of the turbine and then getting killed and stuff like that. So um you would need to worry about things like that. Even though I do remember in the video they mentioned that the turbine has a feature that makes it stop when a creature comes, like sorry, when a dolphin or whatever's living in the water comes nearby. When a living being comes nearby, it stops moving so that it won't get hurt. And that sounds like a great idea. So maybe we can do the same thing here if that thing actually comes to pass as a feasible solution. So yeah, that it is one potential thing that we could do. Although the problem in Singapore really is not just about the wildlife or anything, but really the fact that even though we are covered in water from all four sides, we have a lot of structures already built along all of those four sides, like ports and places for ships to dock and everything. And that means there's not a lot of space for putting turbines. So unless we put it a little bit further out, or we ensure that ships don't end up hitting it or something, it might be a bit hard to do it in general. Right. Water aside, what else can we use? Well, down below our feet, there is a hot magma sea gushing up and down through convection currents. I don't think I need to explain this because it is not a science thing, it's GP also. Anyways, and the heat emanating from the magma can be used as geothermal energy. Well, it's the most useful in places near faults and where the Earth's crust is relatively thin. So this is a very important point. It's only really feasible in places where we are near like volcanoes and faults, and places where the crust is thin enough for us to actually go deep and get the heat from the Earth, like the ground and stuff. So, for example, in Iceland, because Iceland has a lot of geysers, I don't know how to pronounce that, and volcanoes, which sounds pretty ironic given it is called Iceland. And Iceland uses geothermal energy quite well. In fact, it's like 25% of their energy use. But in general, there are some problems to using geothermal energy because geothermal takes forever to get started with. You need to drill like a really deep hole just to do it, and that takes a lot of money, and it also takes a lot of time because you can't drill that fast. And another problem is if in terms of making that hole, if you disturb the ground in some way, it could be having similar issues to fracking. So it could cause like mini tremors or some other release of certain toxic gases from the ground. So yeah, anyways, I mean, if you're fine with the slight risk of stuff happening to the ground, and you're fine with spending a lot of money, would this work in Singapore? There's no point because we don't even face much of any earthquakes or anything of that sort, which is good for us, I guess. But the thing is, that means that we aren't in a location where geothermal would work. We are not exactly along a fault or anything. So the nearest place where we could get such energy is the Ring of Fire, and that would probably be in Indonesia. Yeah. So we are not likely to be using it anytime soon, at least not by ourselves, or like unless we really want to buy it from Indonesia or something. I don't know. We probably won't be using it. So, well, apart from heat, the ground also has many minerals and radioactive isotopes. You know where I'm going with this, right? Nuclear energy. Okay, so let's start with nuclear fission, where you bang a nucleus into some unstable uranium and just break it down into smaller elements. We could go through the science of it, but honestly, if I go into detail, you'll be thinking it's physics class. So, yeah, the thing I just mentioned is the general idea. You bring a nucleus, you put it into a uranium, and the uranium becomes too unstable because of the additional energy, and it breaks down into smaller elements, which continue to break down and continue to hit uranium, more uranium stuff, and it just goes into a chain reaction, and it becomes a nuclear reaction in a sense. So where is this used? Well, in it's used in Europe, in US, and a bunch of other places. And we already know it comes with controversy because it's like one of the things that people are a little bit afraid to have sometimes. It is because of events like the Fukushima plant meltdown and the Chernobyl disaster, or even hidden events like what happened in Navajo Nation, which is basically this area in the US where there's a lot of Navajo tribes. And what happened is the US had this I think like a mining area there, and that meant there's a lot of spillover of nuclear stuff there, and it's not really due to a plant failing, but more of due to the whole practice of them mining it, and they didn't like give any safety protective equipment to the people working there, and it has caused a lot of problems. So you can actually watch it on your own. So is nuclear fission dangerous? Well, not necessarily. Like these events have happened due to safety faults and also safety negligence in some cases. So it's due to that rather than due to it being a nuclear plant in itself. But yeah, there's still risks to it. Even though that risk is teensy weensy and really tiny, kind of like the risk of danger, like the danger risk of flying, is also really small actually. If you manage it well, then you won't have any issues at all. But since there is still that risk, people generally won't want it. They're just too worried about it. Especially here in Singapore, we are so tiny. Like, if you think about it, Singapore is smaller than the Fukushima district, so yeah, we probably don't want any nuclear plant near us. So apart from any potential risk that could happen, there's also the issue of storing the end result of all of that decay, because it's not like uranium just disappears into thin air, it becomes something else. And there's still all these like slightly radioactive stuff that's going on there, and it's just that their half-lives are really long and therefore they don't really decay that easily. So this stuff needs to be kept somewhere in order to prevent it from contaminating something like other places or other soil or water. So this stuff would probably include the spent rods, like so they use rods to do the whole reaction. So all the material is in the rod, and maybe some contaminated water and stuff like that. So this stuff is, dumped into a large lead box, and they just bury this box and hope that nothing happens. But is that even sustainable? Well, in my opinion, I feel like that's an even bigger problem than the fact that there's a meltdown risk in a nuclear fission plant. So that reason is even more like deterring compared to the risk of meltdown. I honestly feel it's better not to have to deal with radioactive waste products. So yeah, something better, cooler, more wonderful has been actually proposed, and that is still related to nuclear energy, and it is in fact nuclear fusion. Yes, it's literally the thing that happens in our sun, and it's the opposite of nuclear fission to some extent. Like the process is considered the opposite, but it's not creating uranium, it's instead creating hydrogen and helium isotopes. So you're basically just mimicking the sun, and you're basically getting some hydrogen to combine into each other. And at most, the only radioactive stuff we have there is deuterium and tritium, which is still just hydrogen, and not as at least it's a little bit less troublesome than some metals that we had to deal with. So you can learn more about these, such attempts to do nuclear fusion. In fact, so the first one is ITER. I don't know how you would want to pronounce it, but it's just ITER. It's just an acronym, ITER, and it's in France. And there's this whole documentary about it, so you can go and listen to it with subtitles if you need. And the more recent efforts are those by China and Spark. So China also participates in the ITER project, and they have their own reactor place to do their experiments. And Spark is basically from MIT, so it's another reactor that is, they're all based on the same concept, which is something called a tokamak. And this thing generates some super hot hydrogen plasma and recreates the inside of the sun. So it's some pretty fun stuff, but you probably don't want to be near. And yeah, that's pretty cool, right? So let's say this actually becomes a thing in the next 5 years or a few years at least. So could Singapore use it? Yeah, I think it could be used in theory, because as long as people accept it and as long as we have a decent, like the right amount of land for building it, we can actually do it. And in fact, it's a whole lot safer than nuclear fission because it's kind of a fail-safe system. So if anything goes wrong, it will just shut down and nothing dangerous will happen. So it's perfect. So much better than nuclear fission in a sense. The only problem here would be getting the fuel source, because hydrogen there's a lot of stuff. I mean, hydrogen is pretty abundant, but you still have to spend energy to get the hydrogen and put it into the plant. So yeah, it's not the most practical thing yet. And we see in, even in the comment section of one of the videos, which is from Seeker. So in the comment section, people are quite skeptical about it being a thing in 5 years. They feel like, you know, even since many years ago, it has been told that, oh, it'll come in another 20 years. Then they just keep saying the same thing again and again, but nothing happens. Nothing becomes a commercial success in the sense. So it hasn't been made practical enough. They're just still doing experiments and trying to make it work. So yeah, we're done. But before I go, I want to talk about some FYI, which is about the Dyson sphere. I told something about getting all the energy from the sun. That's precisely what this does. So it's a proposed energy capture system, and it's named after the person who proposed it, of course. And this is for when we end up having to abandon Earth and take over space. Yeah, truly sci-fi. And it basically involves covering an entire star. Just think of, for example, the sun. Any other star will do the trick. And you cover it with a spherical structure of solar panels. Yeah, so it's basically solar panels to the next level. But as you can think, like the sun is so much bigger than the earth, and so are many other stars. And that means we don't have enough material for all of that. Yeah, that would require a lot of material, and it would also require some really high level technology and rockets to get it to even be fixed and built and assembled and stuff like that. So honestly, yeah, this is hard. It is almost impossible at the moment. And it's also a bit impractical to do it because it just requires so much material and it just doesn't seem very viable at the moment. Like in my opinion, it would be better to try to save Earth instead of trying to think of ways to use some random star to get energy. But anyways, you can watch the video for more. You can just know it for your own information. So yeah, FYI done. So we've covered everything that I wanted to cover, and so what's the final verdict in the sense? What's the final verdict of all of these methods that we've covered? Well, out of these methods, I feel like, carbon capture, if it's more feasible in the future, because I think even though it's somewhat affordable, it could do a bit more cost saving or a bit more practicality that could be used. We could also use solar for sure. 100% you need to use solar because we have so much sunlight here. Also, you could use biofuels and waste to energy, which is very likely to be used in greater amounts in the future. And maybe we could use some underwater turbines and stuff like that. And finger crossed if it works, nuclear fusion, because that would be a game changer if it actually becomes a thing. So whatever the case, as I mentioned, as I kind of implied in a way, not really mentioned, it would be good to have a few sources rather than just depending on one, because we know that they each have their own limitations and stuff like that. So if one of them fails suddenly, we'll still have some electrical capacity until we fix whatever problem there is. And yeah, we have to take this more seriously because we can be quicker in switching to green energy and minimizing our carbon emissions. And more than us, Singapore, the big countries like US and, China is trying, so let's just say US especially, they would really need to do the same. They need to actually spend more effort on converting into greener sources of energy and ensuring that the emissions decreases. Unfortunately, well, yeah, you can tell how the current political scene is going, and I don't think it's gonna happen unless something drastic happens. Yeah, so only then we'll be able to meet our increasing energy demand sustainably, because if, let's say, we just keep doing, using natural gas and fuel and carbon based energy sources, well, fossil fuels may run out, and global warming is not a good thing. We don't want to keep perpetuating global warming. So it's good to start early as possible, and go as quick as possible with regards to these renewable energy sources or even carbon capture. At least do something along that line. So yeah, thanks for listening to the last episode of season one. I know this is a somewhat long episode, but I expected it to be a long episode. So there will be a small break with some other videos before season 2 starts from episode 26. Yeah, so do not think that GPO is going to end forever or anything. You will have a new episode in a few weeks' time instead of immediately next week. That's the difference. And there'll be some design changes, maybe like the slides may have a different font or something like that. That's pretty much it. So I hope you find this particular video useful and interesting because the topic is quite interesting to me at least. Is and since I've told you all this information, maybe it'll be interesting to you as well too, because now you know a lot about these possible energy sources, and hopefully you can think about it in greater detail, or maybe just write about it in your GP essay or something. So if you do find this video useful, please press the like button and subscribe. And with that, I would like to say thank you and bye.